Hello, and welcome to another episode by ES Repair. I am your host, Mr. Fix-It. In this video, I'm going to discuss audio cards. Now, before, many PCs only had a standard or a basic audio system. And over the years, they have increased to stereo, and now they're up to high definition surround sound, such as 7.1. Now I'm going to discuss the things that you need to know before you decide to upgrade your audio card. Now, before you upgrade, there are different features of the audio card. I'm going to show you what to look for when you're buying. You can go up to 7.1 if you wish, but before you begin to upgrade, you'll need to know what operating system you have. You'll need to know the type of processor and the speed. You'll need to know how much free disk space you have. You need to know how much system memory is installed and how much of it is free. You'll need to know if you have a PCI or a PCI Express expansion slot available, or you can use USB or Firewire port. You'll also need to have a CD, DVD drive, or a Blu-ray drive, an optical drive. This will install the software and drivers. You will also need an internet service to download any updates. And your computer must meet the minimum requirements in order for the audio card to function. Now, there are 5 different forms for audio. You have the integrated audio, like this one. These are referred to chipsets that are built into the motherboard. Most of these are found in the South Bridge. If you've heard of AC97, which is short for audio coder decoder, you also have C Media. These are examples of integrated audios. They do provide some high definition audio now. You may have heard it as Intel high definition audio because Intel did change it later. These are built into the motherboard. They don't have as much power as expansion cards do. They do have the drawback they have is that they cannot be replaced. Even if they go bad. I mean, you can upgrade, but you just can't replace them. They're not always powerful enough to be used for extreme gameplay, but rather basic audio such as compact discs and watching DVDs. The integrated audio were just a cost-effective way to free an expansion slot, such as your peripheral component interconnect, which is the PCIe, to where the user can use it for something else. You do have a choice to use PCI and PCI Express audio cards. Now, there's no big difference between the two in performance or anything. The only thing that separates them is the price tag. Expect to pay more for PCI Express audio cards than you will for PCI audio cards. They do not require an enormous amount of bandwidth on the system. They do have advantages over the integrated audio and external audio cards, which I'll show you in a momentarily. They have better sounds. PCI and PCI Express cards, they have high signal-to-noise ratios. They have low harmonic distortion. They have 24-bit sampling rates. They do have 192 kilohertz resolutions and additional application programming interfaces. The additional features does make the sound card worth the time and money it costs to install them. But keep one thing in mind, you will need a good set of speakers or a nice headset to hear the difference. Next, you have the USB and Firewire audio cards. Now, these are a good alternative. If your PC does not have an available PCI or PCI Express slot, then this will be an alternative to use, especially if you have laptops or notebooks, since you cannot change the expansion cards in those as easy as you can with desktop computers. Now, these will provide cost-saving upgrades from integrated audio that are commonly found in PCs. They're easily swappable between computers, and you do not have to open the case to install the card. External audio cards do not have the flexibility as PCI and PCI Express audio cards, but they will provide exceptional recording and playback of audio up to 8 channels. Now, the next thing we're going to talk about is the connectors. Now, the connectors are important because these are connections to your speakers. Now, each channel that they refer to is referring to a speaker. The most basic one is this one, which is your just basic stereo. You have a left speaker and a right speaker. The next one you have is stereo 2.1, which basically all it does is add a subwoofer, as you see here. The next one you can choose is surround 4.0. This has your two front speakers left and right, and it also has your two rear speakers left and right. You can also choose to use a 4.1 surround. This is the same thing as a 4.0, except it adds a subwoofer. The next one you could choose 5.1. 5.1 contains your two front speakers, left and right, the two rear speakers, left and right, a subwoofer, and a center speaker, or a center channel. This is where all your speech comes out of. You can also choose to use 6.1, and what this does is gives you your basic channels as you do in 5.1, except in this case it adds you a rear center speaker, as you see here. Next, you can choose 7.1. This one, you have your two front ones, you have your center channel, you have the two rear speakers, you have the subwoofer, and the only thing they add is now you have side speakers, a left one and a right one. Now, it wouldn't surprise me if somebody comes up with a 9.1 surround sound. Now, that would be interesting to see. The next thing we're going to talk about is the connections. Here you have the connections. This is from the back of my media center. As you can see, it's a 7.1. You have the line in connection, which is a light blue. This can be hooked up to tape decks and other audio sources. You have the line green, which is the line out. This is your main speakers. This is where your stereo comes from if you don't have any sort of surround sound. Next, you have the microphone input. This is a pinkish color. Some audio adapters do provide stereo capabilities for your microphone. And these three connections are the basics to all audio cards. Now, other connections you'll get in surround cards is you'll have the rear speaker connection. This provides your rear speakers, left and right. You have your center and subwoofer. Now, this will vary depending on the channel that you're using, the surround system you're using, whether it provides a center, a subwoofer, or it can provide both. Finally, you have the side, which is usually a gray color. This is for 7.1 audio cards that provide side speakers, left and right. And that's basically all your speaker support. Now that I've shown you the analog versions of your speaker connections, I'm going to show you the digital versions that you can use to connect to other digital home theater systems. The first one I'm going to discuss is called the Sony Philips Digital Interconnect Format, abbreviated as SPDIF. This one uses a RCA cable, which is a 75 ohm coaxial cable that's commonly used for composite video. Now, some manufacturers call this a Dolby Digital Interface, and it has to be an RCA coaxial with an impedance of 75 ohms. If you use regular audio RCA cables, you may not have the desired performance that you are expecting. This cable transmits and receives digital data to and from any external digital source without converting digital to analog. The other connections you have is the optical SPDIF, which is similar to the coaxial, except this one uses a Toslink fiber optic cable that connects to a home theater system and other digital systems that provide an optical input. The optical ones you've probably seen on Blu-ray players and other DVD players. That's what this is. You'll find some audio cards that provides this link. A digital DIN out. You'll find these for multi-speaker digital systems. You'll also find I2S connectors. These are on the high-end versions of audio cards. These connect to other external digital audio sources, which provides 2-channel decoded AC3 audio. They're often from DVD decoders and MPEG-Z zoom videos. The I2S is short for Integrated Interchip Sound, and it's electrical serial bus interface which uses for connecting digital audio devices together. Now it uses PCM audio data streams and between integrated circuits and electronic devices. Now you won't see these very much. You will find them on some audio cards, but there's no standard for the connector. It can use either an RJ45, which is also used for Ethernet, but this is not to be confused with a NIC card. It will use a BNC connector, which is a twist and lock, or it can use a D-sub 9-pin connector, which is the same kind that they use for serial ports. So the I2S can be used for different connectors. Internal connectors include connections such as the CD audio in. These connect to CD-ROM drives analog output to the audio card using a 4-wire audio cable. Now when you buy CD drives, a lot of the times they come with these analog cables. Now these are usually found on older computers and older CD drives. The CD SPDIF connects to compatible CD drives that have a digital output. Now these look similar to the standard CD audio in, but these only use 2 wires instead of 4. Other connections, you have audio or auxiliary in. You may also have video in, such as this one. These connect to additional sources such as a TV tuner or a graphics card that provides analog output. These are internal. Another connector you may find on a card is the TAD in or phone. This connects to internal modems that provides telephone answering device support to process voice messages. You also may find a USB port. Some of these audio cards do provide a USB port. Some are external, others are internal, which allows audio cards to connect to USB speakers, game controllers, and so on. You can also find some audio cards that provide Firewire, which allows audio cards to connect to DV camcorders, scanners, hard drives, etc. Now, all these connectors that I've shown you can be found on the card itself, a breakout box, a daughter board, which is often found in the front part of the computer, or you can find them on an external rack. Now, it is okay to use multiple audio cards. You can have more than one installed. However, the OS, or the operating system, will default to the most recent card installed. But the OS will allow you to switch between the cards as needed. For an example, you can have one audio card that just puts out stereo or 2 channels, and you can have another card that provides 7.1 surround sound, and you can switch between the two. USB based audio cards can be installed without the need to disable the onboard audio device or the integrated audio. Now that we've discussed the primary function of the audio card, I'm going to just show you the other function, or the secondary function, that audio cards can provide. In the primary function, as I've shown, the audio card only decoded the audio that was coming in that instructed as to which channel to play the audio. That's it. For an example, DVDs. The audio on DVDs is encoded on the disc itself, and the decoder just instructs the audio card which channel to play the audio. Games are more complex because the audio card must be able to recreate the intended sound. This is the second function of the audio card. This is the reason why they're called audio sound cards, is because not only do they replay the audio, they can also create the audio or create the sound. Now, surround sound is also known as 3D audio. Now, when you're doing games, there were a lot of problems because software designers had to write code for multiple audio card vendors, and this caused limitations on supported audio cards. As technology has improved, now programmers are allowed to write a single code for the audio. Now, I'm going to show you the different methods designers can use to instruct the audio card the sound to create and which channel to play it. Now, audio cards will identify the methods and the versions that they do support. Games will also show you what they support. For an example, I'm sure everybody knows Microsoft DirectX. Now, this is part of Direct Sound. It's part of the Microsoft DirectX Application Programming Interface library. Now, this will provide low latency interface to the audio card driver. Direct Sound can record and mix. It can also add effects to the sound, such as reverb, echoes, and flange. And it can also use the hardware accelerated buffers and position sounds in 3D or surround sound. Now, Direct Sound 3D, now this is just an extension of Direct Sound, and it allows programmers to utilize audio by writing a single audio API code instead of writing the codes for all different audio cards. Now, since the version 8 of Direct Sound 3D, Microsoft changed it, and now it's just called DirectX Audio. Another version, or another method, is called Environmental Audio Extension. Now, this is a library of extensions to Microsoft's Direct Sound 3D API, and this adds environmental audio presets into the audio positioning mechanism for Direct Sound 3D. Now, with EAX, a developer can set their game's environmental settings, and the audio card will use mathematical digital signaling processing, digital filter presets for the environment. And the latest version for EAX is version 5, if I recall. And that is another one that audio card vendors can use. Another one that you may have heard is called Open Audio Library, or OpenAL for short. Now, this is a cross-platform audio API designed for efficient rendering of multi-channel three-dimensional positioning audio. OpenAL is encoded in 3 general functionalities. You got the source objects, which contains a pointer to a buffer, the velocity, position and direction of the sound, and the intensity of the sound. You also have audio buffers, which contains audio data in either 8 or 16-bit pulse code modulations, or PCM format. It can be either in monaural or in stereo. You also have a signal listener, which is objects containing the velocity, position, and direction of the listener, and the general gain amp applied to all sound. This can work with stereo, 4.0, 4.1, all the up to 7.1 audio output. Another one is called the Aerial 3-dimensional, or A3D. Now, this differs from other forms of discrete positional audio. This one here requires 2 speakers, while surround sound typically requires more than 4. Now, this has a particular advantage of A3D is the dynamic or interactive environments such as simulations, games, video conference, and remote learning. This one here would have a subset of the actual in-game 3D world data to accurately model the location of both direct and reflected sound systems. And this one here was acquired by Creative Labs, which are the makers of Sound Blaster, back in 2000. Another one that you may come across, some games use these, is called the Audio Stream Input Output, or ASIO for short. Now, this provides a low latency and high fidelity interface between a software application and a computer's sound card. This is similar to Microsoft Direct Sound, which is commonly used as an intermediary signal path for non-professional users. It allows musicians, and I do have some subscribers on here that are musicians, and sound engineers to access the hardware directly. It bypasses the normal audio path from a user application through layers of Windows operating system software. Now, this allows different components to directly access the functions on the audio card. And this reduces the latency from one device to another, when the software or the device can directly access the hardware without getting all the other operating system and stuff involved. Finally, I'm going to show you different key features to look for before upgrading your audio card. The first thing you need to look for is the output quality of the device. This indicates the quality of the audio produced by the device. For an example, all standalone CD players sample the disc at 16 bits at a rate of 44.1 kilohertz, and this is the standard for CD players. This is the sound quality that you're listening to. Now, the bit rate, in this case, which is 16-bit, is the number of bits per sample. The kilohertz is the number of times samples are processed per second. Now, audio output quality can go as high as 24-bit at a frequency of 192 kilohertz. Now, there are some that will go as high as 32-bit, but those are rare to see. Most common ones used are 16 and 24-bit, and you can go as high as 192 kilohertz. This will also affect the file size on the hard drive, because the higher the resolution, so to speak, the bigger and the larger the file is going to be. Now, it will produce larger files, but it can be curved depending on what kind of audio format you use, such as WMA or MP3, but I'll explain all those in some other video. The next thing, which is the most important thing that you need to look for in the quality of the audio card, is a total harmonic distortion, or abbreviated as THD. Now, this is a percentage that measures the audio card's ability to reproduce sound. Now, this is the second part that I was referring to earlier. That it can reproduce sound with little distortion. Now, the lower the percentage, the better the audio card can recreate the sound. This is an important factor to consider, because cards use digital to analog and analog to digital converters. A lot of the stuff that you use, whether it's an auxiliary end or a CD in, those are analog. Well, the computer or the sound card has to convert it to digital in order to work with it. And then once it's finished, then it has to reconvert it back to analog in order for you to hear it. Well, that's where the total harmonic distortion comes in. So keep in mind, the lower the percentage, the better the clarity. Another thing to look for is signal to noise ratio. Now, this is abbreviated with SNR, or S with a /N. This is also an important feature to consider. This is listed as decibels and measured in decibels. That an audio card can produce sound with little background noise, which is the hissing noise that you hear, such as those in cassette tapes. The higher the decibel, the cleaner the sound is produced. The next thing to look for is the frequency response. Now, this isn't so major, but it will give you an idea as to what the audio card will respond to. This is just a frequency range. Most cards will respond between 10 Hz to 88 kilohertz. Now, why it's so far out of range, I don't know, but this is the way they make them. I mean, the human ear is only 20 to 20 kilohertz. But a lot of these audio cards could go much broader than just a human ear. Another thing to look for, which is important, is the digital signal processor, abbreviated as DSP. Now, you may notice it mentioned with audio cards and you may not, but you do want to look for audio cards that do have this DSP. It's a specialized microprocessor with an architecture optimized for the fast operational needs for digital signal processing. Now, this will allow the audio card to do all of the processing of sounds, which frees up the CPU to perform other important tasks. So, if you're looking for another video audio card, check to make sure it's got a digital signal processor. A lot of the newer ones do, but they just don't mention it. But look to see if it does. Another thing to keep in mind is the Windows driver model, which is also known as the Windows Driver Foundation. Now, this is a framework of drivers designed to be forward compatible with newer operating systems. For instance, if your sound card was designed for Windows XP, the WDM will load under Windows Vista. However, the WDM will not or is not backward compatible, meaning that Vista's WDM will not load under Windows XP. Now, the disadvantage for using Windows driver model is you cannot use or take advantage of the new features available in the new operating system. For example, XP, even though the driver can load into Windows Vista, it cannot take the advantage Vista offers. Now, Microsoft did replace WDM with Windows Driver Foundation, so you'll notice WDF. And all it is to simplify the driver code writing which is based on its complexity. Well, I'm your host, Mr. Fixit. I hope this video was helpful in understanding what to look for when upgrading your audio card. I do plan on having other videos uploaded. This has been a presentation by ES Repair. Thank you for watching.